Alright, so the fourth problem from yesterday's biweekly contest, length of longest increasing path. We are given coordinates and a integer k, which is representing one of the index from coordinates. So here it is representing the first index element, and we are to find the longest increasing path which includes this particular element. So right away, the longest increasing path, by the way, this definition is like the older problems. We are to find this condition which is true and such that it includes this element, which is mentioned as a particular index key. So how can we do that? Right away, try to solve this question mentally. We'll think of sorting, obviously. So 3, 1, 2, 2, 4, 1, 0, 0, 5, 3. So if I sort it based on suppose the first position, so this will become 0, 0, 2, 2, 3, 1, 4, 2, 4, 1, 5, 3. But right now this is not sorted by the yth position. But if you have solved previous problems, uh, especially there's a problem called Russian envelope. I suggest you solve that before solving this, because this is a little more a sequel to that problem. That one is more straightforward than this. Basically, what we did there is we sorted this like we sorted here based on the first index. But then when the first index is same, suppose this was a 0, 0, or this was a 0, 3, suppose. In that case, we want to find, we want to sort it this way. So if the first index is same, then we need to sort, sorry, we need to sort based on the second index value in decreasing order. Why do we need to do that? So that will come down to a simple straightforward problem which is called longest increasing subsequence, I guess, LIS. That is based on just one dimensional. So suppose we are given 10, 9, 2, 5, 3, 7, 18, or 101 and 18. Suppose we are given this and we want to find the longest increasing subsequence on this. So from 10, what is the longest increasing subsequence? Is just 10, 101. Yeah, I guess that's it. Or I can say 10, 18. Similarly for 9, uh, I can go 9. Again the same thing, I think 101 or 9, 18. Alright. Now for 2, it will be interesting. 2, I can go 5, I can go 7, and then I can go either 101 or 18, right? Or even 2, 3, 7, 101, 18, or even 2, 3, 7, 18. Alright. So 4 possibilities, but the size is always same. I'm sorry. For 5, we can go do the same thing. For 5, uh, basically what we are trying to do is we are doing the n square operation and finding the uh, longest increasing subsequence for each value, starting from each value, and whatever the maximum size is going to be, and that will be our answer. You can keep track of that. That will be of n square. But can we do better? So there comes something called patience sorting, which states that we are going to iterate and we are going to have a bucket or probably a stack. Let me do it using pen. Suppose this is the bucket. I am here. I see 10. Next I see 9. Okay, I have 10, so I would look at a value which is greater than 9. So I have 10. I can put 9 above. I'm sorry. 2. I see 9. I'll look for a value which is greater than 2. I see 9. So that's good. 5. I see that there is no value which is greater than 5, right? At least at the top. So I'll create a new bucket. I'll place 5 here. I'll look for the top of the buckets and look for a value which is greater than 5. So I have, sorry, greater than 3. So I have 5. I'll move. I'll see for a value greater than 7, which is not there. Similarly, 101, not there. 18, yeah, it's there. So this will be my longest increasing subsequence 2, 3, 7, 18. That's what we need. So since we have sorted this, and we have sorted y coordinate in decreasing order, we can do a LIS on y coordinate, and since we are given a k, we are to we need to be careful about situations where suppose this is the example. Instead of these many values, I have these extra values as well. 5 comma suppose 1 7 5 comma 4 even 0 6 comma 8. So if I sort this, this will become 3 1, sorry, 0 0 3 2 1 2 2 3 1 4 1 5. So we have equal coordinates, so the one which has greater y will come first. 5 1 5 0 6 8. So this is I'm sorry. So this is what we'll get for after sorting. But suppose we are given k as this particular index, we will do a LIS on this half. We'll do a LIS on this half, but we will make sure that whatever coordinates we are doing a LIS on, both of the coordinates must be lesser than the coordinate that we are interested in for the left half, but for the right half it should be greater than. So we are going to consider this as the right half and this as the left half, because 5 3 have 5 in common, 5 0 have uh, again 5 in common, but we are not we are not going to consider this one. This one we are not going to consider. Why? Because so these are the ones we are not going to consider because 1 is equal, here 5 is equal, here 5 is equal. So all of the other coordinates in the left half should be strictly lesser than the one that we are interested in. For the right half, it should be greater strictly. So that's what we are going to keep track of. All right, so let's code it up. I'll get the size here. Uh, I'll sort this, but before sorting, I should get the values, right? Because after I sort, I would lose the track of which element needs to be included, right? So let me get A, and by the way, I'm getting the values because in the constraint it's mentioned that all elements are distinct. So the pair will be unique. So K1 or 0 will be the first value, and this will be the second value. Let me sort this now. Okay, coordinates dot begin and coordinates dot end. Here, let me add a comparator so that I can uh, sort the second index based on decreasing in a decreasing order. So if LHS of 0 is equal to RHS of 0, in that case return LHS of 1 greater than RHS of 1. Otherwise, return LHS of 0 less than RHS of 0. Now I can just reverse. I will check if this particular value is equal to A or if it's equal to B. In that case, continue. Otherwise, I'll also have the left half or the right half. But instead of having the left half and the right half, I can just straight away have the left half LIS and the right half LIS. So left LIS and right LIS. Okay. If this particular value is not equal to A and B, and if its first coordinate is less than A and the second coordinate is less than B, in that case I can call the LIS function which I will be creating. So find LIS or update LIS, which will update the left LIS for this one, because since it's lesser than both the values, it's in the left half. uh, and what is the value? I'll pass the value as well, right? This is the value, and I'll have this value and I'll do a patient sort using this value. I'll look for the top of the buckets, whichever has the larger value than this one, I will put it in that. Otherwise, I will uh, create a new bucket, which means update the, I mean, Yeah, create a new bucket, which means add the value in the list or the LIS. I'll do the same thing for. By the way, I will call using the Y coordinate because uh, I'm doing LIS on the Y coordinate. So for the right half, I'll do the exact opposite. There is a brace missing. Okay, that's an extra brace. Greater than B and greater than A. Then I'll call the LIS for the right half with the Y coordinate. And finally, I will have answer equal to 0, answer plus equal to, actually answer, I can just return, I don't need answer, left LIS dot size plus 1 plus right LIS dot size. Why plus 1 here? Because the value that we are found, like the value that needs to be included in the question itself, that's what we do the plus 1 for. Now I'll create, actually this will be a void because this will be updating the LIS based on the binary search. I'll do a binary search, by the way. Since we are at a particular value x, so that will be checked against all the buckets. Instead of doing that, I will do a binary search and find the particular index which is just greater than or equal to this x. So I'm doing a lower bound, right? Update LIS. This will be having vector of LIS comma the value. So I will do a binary search. So I'll get the iterator or the iterator lower bound on lis.begin comma lis.end with the value if this particular iterator gives me nothing, which means it gives me lis.end, then I don't have any choice. I will uh, take this in my bucket. So by this I mean the value. So this, otherwise I will update this particular, oh sorry, this value, not this iterator, this value. Otherwise I will update this particular index value with this value, right? That's what we did, right? So if I found that there is something 9 which is greater than 2, so I'm essentially pushing it in this bucket, but I don't need these, right? So I can just replace 9 with 2, and when 9 came, 9 replaced 10 with 9, right? So I'm just doing that and return. That's it. Let's see if this works. Okay, coordinates dot end lis dot begin with braces. The time complexity will be O of n log n just from the first sorting, and the second sorting will also be O of n log n because we are doing a lower bound essentially for every value. So O of n log n will be the time complexity. Space complexity will be O of n. Okay, this time limit exceed. Let's see if we can do some optimization. We can pass it by reference. This might optimize it. Let's see and submit. This works, yeah. It does work. It's a little weird in terms of time complexity, but yeah. Okay. Thanks, guys.